This is a change of base law, but it isn't that somebody said, now I will make up a law about the change of base and here's how it'll go. It's just something that happens to be true, like 2 plus 3 is 5. Nobody said, hey, let's make 2 plus 3 equal to 5 and let's make 2 to the third equal to 8. It is. Once you make up the notation for what this means, it is equal to 5. You can show it's equal to 5, right? It's going to be the same thing here. This is called we're calling it a change of base rule or law, but it's like a shortcut, okay? It's more like just realizing it's a shortcut, that we're going to see where it comes from by solving this a couple different ways, okay? And you've already done this before. You need to solve this by taking the base 10 log of both sides and not necessarily getting a decimal, but writing the expression for what it is when you solve it. And then find what x is equal to by taking the base 3 logarithm. And of course, you use your calculator for that? Well, it depends. Most calculators you can't. And then out of that is going to come the change of base rule, because you're going to have one expression here, and you're going to have one expression here. This is going to involve base 10 logs. This is going to involve base 3 logs. And you can write yourself a rule that those are equal. Then you can write a rule using a's and b's here, or variables of some sort. I'm going to pause this while you try that. And then maybe I'll write something out that you can check. Okay, hopefully you're able to try solving that two different ways. I mean, one is the way you're going to be able to use your calculator to do it. The first way, base 10 logarithms. 3 to the x equals 7. You might be getting pretty good at this now. If you take the base 10 logarithm of each side, that'd be a good idea to turn that off. If you take the base 10 logarithm of each side, you get x log 3 equals log 7. And then if you solve that, you're going to get x is equal to log 7 over log 3. Okay? If you did, that's using base 10 logarithms. If you did the same thing by using base 3 logarithms, even though you don't have that on your calculator, or you might, I don't know. Even though you don't have that necessarily in your calculator, you can still do it. This allows you to just get right away to x is log base 3 of 7. So doing it the way up here, doing it this way, you end up with x is log 7 divided by log 3. If you do it this way down here, you get x is log base 3 of 7. Okay? Log base 3 of 7. So what does that tell us? What could this be? Why could this have anything to do with the change of base rule? The fact that we got that is equal to x and that is equal to x? What might we conclude now? What could we say has to be true? Yeah, log base 3 of 7 has to be equal to log 7 over log 3. This is essentially the change of base rule if you want to change something to base 10. You can write it down here with variables, right? I'm going to move it just temporarily so I can see this part of it. We'll put it down there. But we're going to write it with variables, and then as you write a rule, right? Log base 3 of 7. So if I say log base a of b, what's that got to be equal to? Log b over log a, right? That's the change of base rule. This is in general with variables, a's and b's. This is specific to that thing that we just looked at. I'm going to move this back up here because there's one other thing we could do with this. What if I had solved it one more way here? If you're ever changing the base of something, why might you want to change the base of something? A 3 to the x equals 7. When we're solving that, the two choices we had, you could make an argument for why you'd use base 10 logs, and you can make an argument for why you might use base 3 logs. Is there any argument for any other kind of base? Give me a ridiculous number that we could use as a base to solve this thing. 800? Okay, log base 800 of both sides. Log base 800 of this should be equal to log base 800 of this. So log base 800 of 3 to the x should be equal to log base 800 of 7. It's true, right? As long as you do the same thing to both sides, which we did, we took the log base 800, I can still follow it through the way I did before, because I can take this thing and put it in the front, right? And what am I going to get here? I get x times log base 800 of 3 equals, oops, I forgot the 7 there, log base 800 of 7. And then how could I write what x is? Yeah, absolutely. This thing can go down there, right? You can divide by that, and it's just going to be this, right? X is equal to that. How does that compare to what we just had up above? Let's bring this over here. Because I could have used any base. You just gave me a number, right? You gave me a random number there. How does this compare to, where is it over here? Over here. What is that equal to? We started with, what would be the other way that it's going to, if we do this, now if I put log base 3 of 7, because it's the same thing I solved, right? If we have that, which statement do you like better? You like this one? People don't like this one for some reason. Doesn't it say exactly the same thing? Why does the other one seem simpler? Because it doesn't have those 800s there, right? It's, other than what's in red, other than the two 800s, it's exactly the same rule. In reality, you're never going to change it to base 800 or any other base that doesn't make any sense. You're going to change it to base 10, or there's one other base you haven't learned about that you might change it to. Except that it's Math 12 and you're asked ridiculous questions that change this to base 4, or something that nobody uses, right? I could have used any base there. In fact, I could have made this just a C or something like that, right? So the other way you can write this change of base rule is to write it exactly the same way as this. I'm going to recopy this. You can actually copy it. One more time over here. And I'm going to put two things in there to slightly change this. What's the way I can change this to make it look like what I just had? I didn't have to use base 10 here, right? I could have used any base I wanted. So I'm going to put a C here to say this could be any base you wanted, right? Does this still look harder than the other one? Because of those two C's? No, not at all, right? You're rarely going to do this because why would you change it to a base you don't have in your calculator? But it's important to know that that works. I don't know if there's any words you can explain for yourself the significance of that in a minute or two. You can write something down there, and then you can try some of the questions that are in here. All right. This says I'll go back there in a second. This says log base 8 of 70. I want you to write 3 different expressions for what you could change that to. What is that equal to according to the... If you want to evaluate this and you don't have a log base 8 button, you could certainly use base 10. What would I write? What could I write? Yeah, log 70 over log 8. There's actually another button you have. You know that you have a log button and you have a 10 to the x button on your calculator? You also have one other logarithm on there. On any scientific calculator, it'll have this one. There's log and 10 to the x. There's actually this thing and e to the x. E is a number you maybe have never used before, but this is called natural logarithms. They have every day, if you're a biologist, you're going to be using natural logarithms all the time, in chemistry with radioactive decay and stuff. All of these things involve real natural phenomenon. We don't really use natural logarithms, but they are there. natural logarithm, even though you don't know what a natural logarithm is, this is also equal to natural logarithm of 70 over natural logarithm of 8. Or it's equal to log base 261 of 70 over log base 261 of 8. For some reason, it always helps people if I change this to a different color. It's just whatever the base is, right? Especially if I change it to a color like pink. Right? Any base you want. Most often, you're going to change it to that, or you could do that, because those you can evaluate on your calculator. But in Math 12, you get silly questions like, I asked you a lot of questions there. You might actually be ahead of this now, but this is asking you to do, to kind of do some more discovery of this. You may well be ready to, now I have a place here you can write the change of base rule. You can write it again if you want. We wrote it back before that, but whatever. You should try some of these questions. They're going to look different. It isn't that, it's going to be better if you do these by trying them rather than me saying, here's how to do this one, here's how to do this one, here's how to do this one. You should try some of them. They get to the point where you're going to have to do a bit of thinking about this. And I know what you resort to sometimes when you're asked to think is you just stop. That's what a lot of people do. And say, this is stupid if it's hard, right? As soon as it's hard. I've noticed this over the years, right? If I give my grade 8s grade 2 level work, they're all quiet, they work on it, they sit there. They don't care that they already know how to do it and everything. As soon as you give them difficult stuff they have to think about, that's when problems start happening. And they say, this is stupid, and we go from there. So when you encounter things like this, don't say, this is stupid. It's a difficult question. It's meant to be, right? Maybe even this one's gonna bother us, but we think about it and try. And again, going through the process of thinking and getting not very far, and then talking about it after, that's going to help your learning rather than me say, here's how to do this one, here's how to do this one, now go home and memorize it all. That's not what I want you to do. Okay? Can you try some of those questions and the ones from the previous tutorial? You can use time that you have here, and hopefully we're good by the time we're done.